Okay, so in class we also talked about hypothesis testing for proportions. So I kind of give you guys the steps on how to do it. Another way that I can set up problems like this is just by giving you guys A, B, C, D, and kind of like guide you guys through the problems because these can be a little bit difficult to start off. So this problem says, according to the U.S. Census Bureau, the current proportion of male nurses is 9%. We randomly select 500 nurses and find that 70 of them are men. Has the percentage of male nurses increased? Okay, well, if you can see, before you even do the problem, you can just take 70 and divide it by 500. And if you take 70 by 500, what you get is 14, so 0.14. And basically, you can see that 14% is much larger than 9%. So that's why we are asking if the percentage or the proportion of male nurses has actually increased. Okay? So now what we're trying to figure out for part A, we want to find the null and the alternative hypotheses. So remember that the first thing that you want to do is set up your HO and set up your HA. Since we're talking about proportions, the parameter is going to be P. So initially, what do we believe? We believe that the proportion of male nurses is 9%. So here our P is going to be 0.09. So be very careful because remember that 9%, you have to switch the decimal place 2 times over. So this will be 0.09, not 0.9. Now, HA here, since we're looking for the percentage of males has increased, that gives us a clue that says that this is going to be a greater than sign, and then 0.09. Okay, so this is my null hypothesis and my alternative hypothesis. This basically says that percent has not changed. So we don't have enough evidence to say that there has been an increase. This one means that it has changed, that percent has increased. So if we do our hypothesis test, it might tell us that, okay, it actually is enough information. Okay, so now part B says, is this a one or two-sided test? Okay, well, in order for me to determine if it's a one or two-sided test, what we need to look at is our alternative hypothesis. And we see that since it's greater than, we know that our p-value is going to be on one side. And in this case, it's going to be on the right-hand side. So no, this is not a two-tailed test. It is a one-tailed test. And more specifically, this is going to be a right-tailed. Okay, so that's what we have. Okay, and the reason why is because you have a greater than sign. So whenever you have a greater than or a less than sign, you have a one-sided test. Whenever you have a not equal to, which is what we're going to do in the class this upcoming week, it will be called a two-tailed test. Okay, now what we want to do is find the p-value. So our p-value here will be this shaded region. Okay, so let me draw it one more time. Okay, so my p-value is going to be this region. Now we know what this test is. We know what our data is. The data that we gathered, our p-hat, was the 70 out of 500 nurses. So 70 out of 500 we said was 0.14. So this is equal to 0.14. Now, before we can figure out our p-value, remember that we need to figure out the mean, and we also need to figure out the standard deviation or standard error. And those, we actually know what they are. Okay, so the mean is just p. What was p? Well, our p is under the null hypothesis. We wrote it down here. That's just a 0.09. So this is 0.09. Okay, and what is going to be my standard error? And if we remember, the formula is square root of p, 1 minus p divided by n. Okay, so we're going to do the square root of 0.09, 1 minus 0.09 divided by n, and n was 500. Okay, so now what we're going to do is put this into our calculator. So put 0.09 times 1 minus 0.09 divided by 500. Let's round this to about 3 decimal places. I'll get 0.013. Okay, so that's my standard error. Okay, so now we figured out our mean. Our mean is right here. This mean is 0.09. And you can see that actually 0.14 should be to the right of 0.09. Now, in order for me to find my p-value, what I gotta do is use Normalcdf. Okay, so Normalcdf with my bound. My bound in this case will be, my lower bound will be 0.14. My upper bound will be positive infinity. Okay, a really, really big number. My mean in this case, I'm going to write mean is equal to 0.09. My standard error is going to be 0.013. For those that have the TI-36 calculator, this will be sigma. Okay. All right, so now what is this going to give me? So I'm going to put this into my calculator. I'm going to go to Normalcdf. My mean was 0.09. My standard error was 0.013. My lower bound was 0.14, and then all the way to infinity. And what I end up getting is 0.00006. Okay, so that's what my p-value is. So very, very low p-value, which is kind of already, you can probably guess what we're going to do. Okay, so at a 5% significance level, so this is actually my alpha. Okay, my alpha is 0.05. Okay, can we reject the null hypothesis? Well, I know what my p-value is. My p-value is this 0.00006. Well, in this case, my p-value is low, so we can reject HO. Okay, so we can reject our null hypothesis, okay, because our p-value is very, very low. Okay, so what can we conclude based on our test? Okay, so since our p-value is low, okay, we have enough evidence to say that the proportion of male nurses has increased. That's basically what this low p-value can tell me. Okay, so just because this low p-value is low, we can reject this claim, this thing, and we can say that the claim that the percent has increased is actually true based on this sample. Okay, so this is just based on the 500 nurses that we sampled. Okay, so that's basically what we can conclude. Okay, now my next question, which is actually a really good question, is what would change if this was a two-tailed test? So instead of being a one-tailed test, what about if our null hypothesis looks something like this? P is equal to 0.09, and then HAP is not equal to 0.09. Well, what would happen now is that, well, P is here, 0.09. Now, we no longer just have this on the right-hand side, we also have it on the left-hand side. So what this tells us now is that we have two p-values, okay? And because we know that this is symmetrical, since the p-value here is 0.00006, what we would do is multiply this thing by 2, because now that means this is 0.00006. This thing is also 0.00006. So what we're going to do is you can either add these two together or you can multiply it by 2. So this will be another p-value that we would have. So our p-value now would change from 0.00006 to 0.00012. So now my p-value would actually increase. Okay, so our p-value actually increases because we're multiplying it by 2, and that's the only time that you would do that, because you have a not equal to, which means that you have two different p-values. So your p-value can either be to the left-hand side or to the right-hand side. Okay, so hopefully this helps.